Today we're going to be learning lesson 1.3, real numbers and the number line. Our goals for today are to classify, graph, and compare real numbers, and to find and estimate square roots. So first we need to go over some vocabulary about square roots. The definition of a square root is if a squared equals b, then a is the square root of b. What that means is if you have a number, say 4 squared equals 16, 4 would be the square root of 16. Now a radicand is the expression under the radical sign. So here's the radical sign. The number inside here, the 16, would be the radicand. Now a radical is formed by the radical symbol and the radicand. So the radical is this entire thing. A principal square root is the non-negative square root. So this right here would be the principal square root. Now a perfect square is the square of an integer. So we'll use the same example, 4 squared equals 16. 16 would be a perfect square because if you square 4, you get 16. Let's try some examples. So here, we've got the square root of 81. I need to find some number squared that's going to give me 81. That number then would be the square root of 81. So think about 9 times 9. 9 times 9 equals 81. So 9 squared equals 81. So the square root of 81 is 9. Now when you're dealing with fractions, you're going to take care of the square roots, or the numerator and the denominator separately. So I have to think of a number squared that's going to give me 1, a number squared that's going to give me 36. Well, 1 squared would give me 1, because 1 times 1 is 1. 6 squared would give me 36, because 6 times 6 is 36. So my answer would be 1 over 6. Square root of 25, some number squared has to give me 25. Well, 5 times 5 is 25. And then 9, some number squared should give me 9. Well, 3 times 3 is 9. So my square root is 3. We can also use what we just learned to estimate square roots. Now when you're estimating square roots without a calculator, right, you need to think about the numbers you have and think about perfect squares. I have 17. If I think about my first example, I know that 4 squared equals 16. That's close to 17, but 17 is bigger. So I'm going to go up one number and see what 5 squared is. Well, 5 squared is 5 times 5, which is 25. It asks me to round to the nearest integer, which means the nearest number that's not a fraction. Well, between 16 and 25, I would say that 16 is closer than 17. So I'm going to estimate this square root to be 4. 35. Well, let's start with 5 squared, because that was 25. Okay. 6 squared will go up, because I'm not quite at 35 yet, is 36. Well, which one is closer, 25 or 36? 36 is closer to 35, so the square root, our estimate, would be 6. Now 61. These aren't really close, the last ones we used, 25 and 36 to 61. So I'm going to go up another number. 7 squared equals 49. 7 times 7 is 49. I want to go up another one and see what 8 squared is. Well, 8 squared is 64. Well, 61 is in between these two numbers, but 61 is closer to 64, so 8 would be my estimate. Okay? So that is square roots, how we find a square root. We also need to talk about real numbers in general. Okay? Now this is important vocabulary for this section, so if you need to pause the video, go ahead. Okay? I'm going to go ahead and skip through sets to subsets. You can write this all down, and I'm going to talk about different types of numbers we have. So we have rational numbers. Rational numbers is any number that can be written as a fraction. Now be careful, it doesn't just include fractions like 5 over 4, but 6 would be a rational number because any whole number can be written as a fraction if you put it over 1. Okay? Also, square root of 25, that would be a rational number. Because I know the square root of 25 is 5, well, I can write 5 over 1. Natural numbers, another name for natural numbers is counting numbers. Think of how you count. You count 1, 2, 3, 4, 5. You don't start at 0. So natural numbers start at 1 and keep going up, right? They can't have any fractions or decimals in it. Now, whole numbers are like natural numbers, but they start at 0. So there's no negatives, they start at 0 and they go up. There's no fractions, there's no decimals. Integers are like whole numbers, except you can have negatives. So, still no fractions or decimals, but you can have negatives, you can have 0, and you can have positives. Irrational numbers are the opposite of rational numbers. They cannot be written as a fraction. If it's in decimal form, irrational numbers do not repeat, so you won't be able to find a pattern, and they do not end. So for example, pi would be irrational because it's 3.14159 and it keeps going on, right? It never stops and there's never a pattern. Another example, the square root of 3, that would be irrational. If you find it in decimal form, it's 1.73205080 and it keeps going, right? It never ends and you can never find a pattern. So let's put this into a visual form. So here's all of my types of real numbers: rational, integer, whole, natural, irrational. Right? Irrational is on the side of its own because, right, it's by itself. So for example, we've got the square root of 10, the negative square root of 123, pi was another one. Okay? Natural numbers, some examples, remember it can't include 0, so I'm just picking some examples. Okay, but it's all positive numbers. What natural numbers lack is 0. Okay? Whole numbers are all positive numbers and 0. So if you have a number that's a natural number, it's also going to be a whole number, right? Because 7 is natural, but 7 is also whole. Whole numbers, remember, including 0, then are positives. Integers, we start adding negatives. So anything that's a whole number would also be an integer, right? Because integers can be positive, negative, or 0. They just can't be fractions. Now, rational numbers, we start including fractions. Okay? Decimals are also, they can be written as fractions, so they're also rational numbers, right? But if you have a natural number like 25, it is also a whole number because 25 is in that set. It is also an integer, and it is also a rational number because 25 can be written as a fraction. So let's try an example. So this one says to which subset of the real numbers does each number belong? So basically we're saying, is it whole, natural, integer, and so on. Well, 12 I know is a natural number because it's a counting number. I can count up to 12. But 12 is also a whole number because it's positive and it's not a fraction. Well, integers can also be positive. So 12 is also an integer. And since 12 can be written as a fraction, it is also a rational number. Now for b, since I have a decimal, I know it can't be a natural, a whole, or an integer, okay? But this decimal right here, since it ends, it is rational, because I could write it as a fraction. Now c, the square root of 21, if I find the decimal form of that, it's 4.58257, and it continues. There's no pattern, so it is irrational. Okay, so what we'll be doing next is looking at applying what we've learned to real numbers. That'll be on the next video, so please go to the next video.